In this lesson, we want to review finding the equation of a circle, and we also want to review how to graph a circle on the coordinate plane. So I know for most of you, you've already taken an intermediate algebra course, and so when you studied conic sections, you talked about circles, you talked about finding the equation of a circle, you talked about graphing circles on the coordinate plane, so this is just a review for you. For others, you might not have ever seen this topic before, and I can assure you that this is a very, very easy topic to learn, and you'll be able to pick it up from just this lesson. So let's just start out by talking about the definition of a circle. So in your textbook, you'll probably read that a circle is just the set of all points in a plane that lie a fixed distance from its center. Okay, a fixed distance from its center. So the fixed distance from the center to any point on the circle has a special name. It's known as a radius. Okay, so let's write radius here. We're going to hear about this throughout our lesson. And generally, we denote the radius with the lowercase r. Okay, so when you see the lowercase r, we're talking about a radius, and this is what we're referring to. If you look at the center here, which I've put as h comma k, and we'll talk more about that in a second, and you look at this point here, which I've labeled as x comma y, we'll talk more about that in a second. This distance from the center of the circle to this given point is going to be the radius r, okay? And it would be the same if I put a point here on the circle, and I drew a line from here to here. That distance would be the same as this one that's already drawn. Or if I put a point here and I drew a line from here to here, all of these would be the same distance, okay? So let me erase this. And let's talk about some other things you'll see with a circle. So generally we denote our center with h comma k. The h is the x value, the k is the y value. So h comma k, all right? In this particular case, we have actual coordinates. The center occurs at -4 comma 4. Okay, but generically, we would say that this is the center when we're working with a circle, okay? And then a given point could be labeled as x comma y, right? If we don't know the coordinates in advance. In this particular case, what I've labeled as x comma y, we already know this would be 1 comma 4, okay? But we can refer to a point on the circle as just x comma y. So the reason I talk about this is because we're going to use kind of the concept of the distance from the center to a given point to derive an equation for a circle, and this comes from using our distance formula. So let me show you this equation real quick, and then we'll show you how it gets derived. So if we look at this center radius form of a circle, this is also called standard form. You have this x minus h, this quantity squared, then plus this y minus k, this quantity squared, and this equals r, the radius squared. So if you have an equation in this format, it's very easy to graph the circle because you're going to know the center of the circle, which would occur at h comma k. So you have your h and you have your k. So immediately I can say, okay, this is my center. And you're going to know your radius, right? It's the r, not the r squared, it's the r. So I would need to take the principal square root of r squared to find the radius r. Now, why don't I want the negative square root? Well, because the radius is a distance, and I don't want to end up with a negative distance. So where does this equation come from? A lot of times we see these equations and they're given to us, and it's really cool to just be able to kind of plug in and do your homework, but I want you to understand where it came from. So let's talk a little bit about that. Let's revisit our distance formula that we've worked with so much in this course. So we know the distance between any 2 points is equal to the square root of, we have the x sub 2 minus x sub 1 squared, plus the y sub 2 minus y sub 1 squared, okay? So the difference in x value squared plus the difference in y value squared, this is under a square root symbol, okay? So in this particular case, we know what? Let's say we have a given point of x comma y, and we have a center that is h comma k. So these are 2 points that we know, okay? And we know the distance between a given point on the circle and the center is the radius. So I know that the radius would be my d, my distance between these 2 points. Okay, so I can say r is equal to the square root of, and then I can just kind of plug in for these kind of points. Normally I work with what? I have x sub 1, y sub 1, and I have x sub 2, y sub 2 that I'm dealing with. Well, in this case, I can just let x comma y take the place of x sub 2, y sub 2, and I can let h comma k take the place of x sub 1, y sub 1. So let's just set this up and say that we have x minus h. Okay, I just took this guy minus this guy, so it's still the difference in x values, and then I'm squaring that. And then plus, I would take the difference in y values. So I'm going to go y minus k. So y minus k. And then this quantity squared. So let me erase all this just so we have some room to work. Okay, so let me scooch this back up. And so all we need to do to get into our center radius form is just square both sides. if I square this side and I square this side, we know that this guy right here is going to cancel with this index here. And so I can just basically remove this, and then I have my center radius form, right? I can flip this r squared around because normally it's on the right side of the equation. So I can just say it's x minus h, that quantity squared, plus my y minus k, that quantity squared, and this equals r squared, okay? So exactly what we saw on the previous page, right? X minus h, that quantity squared, plus y minus k, that quantity squared, and this equals the radius squared. So that's where this equation comes from. So one of the first kind of tasks that you encounter in this section, you're going to be given a center and you're going to be given a radius, and they're going to say, write the equation of the circle in center radius form. So all you have to do is just kind of match things up. So again, we have the quantity x minus h squared, then plus we have the quantity y minus k squared. This is equal to the radius squared. Okay, so I'm just going to plug in. I know my center occurs at h comma k. So this guy right here, this 4 is going to be my h, and this guy right here, my 5 is going to be my k. Okay, so I'm just going to plug in. I'm going to plug in a 4 here, and I'm going to plug in a 5 there. And then for the radius, it's the square root of 7, so I'm going to be plugging that in there. Okay, so what do we have? We'd have the quantity x minus 4 squared, then plus the quantity y minus 5 squared, and this equals, if I take the square root of 7 and square it, I just get 7. So this is my center radius form for a circle with a center 4 comma 5 and a radius of square root of 7. All right, let's try one more of these and then we'll just kind of move on to something that's a little bit more complicated. So we have a center that occurs at negative 13 comma negative 2 and a radius that occurs at the square root of 11. So again, let me rewrite our center radius form. This is x minus h, this quantity squared, then plus you have your y minus k, this quantity squared, and this equals the radius squared. Okay, so again, this is going to be my h, and this is going to be my k. Now you have to be careful here because you have a negative 13 and a negative 2, okay? So you have to match this up perfectly. If I'm plugging in for h, and h is negative 13, what I have here is minus a negative 13, okay? So minus a negative 13 is plus 13. So I've got to be careful. So I'm going to say x plus 13, this quantity squared, okay? A lot of students make the mistake when they have a negative involved, they just plug in kind of, in this case, you'd say I just plug in x minus 13, okay? That would be wrong. So then plus, I'm doing the same thing here. I'm plugging in a negative 2. So y minus a negative 2 is the same thing as y plus 2, and this is squared. And this equals my radius. I'm going to plug in the square root of 11 there. So the square root of 11 squared is just 11. Okay, so x plus 13, this quantity squared, plus y plus 2, this quantity squared, and this equals 11. That's the center radius form for this circle that has a center of negative 13 comma negative 2 and a radius of square root of 11. All right, so now let's move on and talk about something that's a little bit more complex. So we also have a general form of a circle. Okay, so when it's in general form, generally you have to do a little bit of work. You're going to use the method known as completing the square that we talked about with quadratic equations, and we're going to put it back into our standard form or our center radius form. So general form of a circle looks like this. You have x squared plus y squared plus cx plus dy plus e equals 0. And basically this guy can be obtained if we start with our kind of standard form and we expand those two kind of binomials that are squared. Okay, so for example, let's say I start with this guy. So I'm going to start with this, I'm going to put it in general form, and then I'm going to go backwards and I'm going to put it back in kind of standard form. So the first thing I'm going to do is just expand these two right here. So if I do that, then x minus 3, that quantity squared, we know that's x squared. We know it's minus 2 times this guy times this guy. So 2 times 3 is 6, 6 times x is 6x. And then we know it's plus this guy squared. Then we'd have plus, I'm going to have y plus 2, that quantity squared, so this guy squared. Then plus 2 times this guy times this guy. 2 times 2 is 4, 4 times y is 4y. And then plus, we have this last guy 2 squared, which is 4. This equals 9. Now I can combine some things here. I can write this as x squared, and then minus 6x. And then I'm going to put plus y squared, and then plus 4y. And then 9 plus 4 is going to be 13. But before I do that, realize you have a 9 here and a 9 here. If I subtract 9 away from each side of the equation, it would cancel, right? So I can just put plus 4 equals 0, and that would be my general form, okay? So from this, I can go back to this. So let's say I'm presented with this, and I'm asked to kind of put it in standard form. Well, essentially what I want to do is I want to complete the square, right? What is completing the square? It's where you create a perfect square trinomial, right? A perfect square trinomial can be factored into a binomial squared, right? That's exactly what we have here. We have a binomial squared and a binomial squared. So we're going to need to kind of add a number to this guy to get a binomial squared. We're going to need to add a number to this guy to get a binomial squared. But there's some things we need to do to make sure that's legal. So let me scroll down. We'll come back up to this when we're done. So the very first thing, in case you forgot how to complete the square, is to move the constant to the right side. So I'm just going to subtract 4 away from each side of the equation. And that's going to give me x squared minus 6x plus y squared plus 4y is equal to negative 4. Okay? That's the first step. The next thing you want to do is make sure the coefficient of all the square terms, so we have x squared and we have y squared, you want to make sure this is a 1. Now in this case, this is an easier example, so it's already done for us, so we don't have the additional work. But if it wasn't, you would need to divide, right, both sides of the equation by whatever was necessary to kind of clear that. All right, so now what we want to do is group the x terms together and group the y terms together. That's kind of already done for us, but what I'm going to do is I'm going to just wrap them in parentheses. So I'm going to say this is x squared minus 6x. And then I'm just going to put a blank space here because we're going to add something to that. And then plus, you're going to have y squared plus 4y. I'm going to put a blank space because we're going to add something to that. This equals negative 4. All right, so what we want to do now is kind of the step that everyone forgets. We want to take 1/2 of the coefficient of the first degree term squared, and we want to add that to each side of the equation, okay? So in this particular case, again, this variable is raised to the first power, this variable is raised to the first power. So I look at the coefficient. This is negative 6. What is 1/2 of negative 6? A lot of times they say cut it in half. Just divide it by 2. That gives you negative 3. Once you get that, you want to square it. So negative 3 squared would be 9. So I'm going to add 9 here. But to make it legal, I've got to add 9 on the other side of the equation. So I'm going to add 9 over here as well. Then I'm going to do the same thing over here. If I take 4, this coefficient for y to the first power, and I cut it in half, 4 divided by 2 is 2. If I square 2, I get 4. So plus 4. But again, to make it legal, I've got to add 4 on this side as well. Let me erase this. Let me kind of scroll down. And so what I end up with is exactly what I started with, right? If I factor this now, I would have x minus 3, that quantity squared. Then plus, if I factor this, I would have y plus 2, that quantity squared. And then negative 4 plus 4 is 0. Then I just have positive 9. So this equals positive 9. So if I look at this guy right here, I can see it's exactly what I started with. If I go back up, so let me just kind of paste this in so we can kind of compare what we have. So we started with the standard form, x minus 3, that quantity squared, plus we have y plus 2, that quantity squared, and this equals 9. Then we expanded our binomials, so we got the general form, right? X squared minus 6x plus y squared plus 4y plus 4 equals 0. That's general form. And then we went through the process and we completed the square for each, and we ended up with the standard form again, right? So we went from standard form to general form back to standard form. So it can be tedious in some situations, but not really a hard process overall. As long as you understand how to complete the square, it's pretty easy. All right, let's look at another example of this, and then we'll move on and talk about graphing, okay? So let's suppose you're given this equation here, which is a circle in general form. So let's say you're asked to put it in standard form. Again, you're just going to go through the process. So the first thing I want to do is move this guy, this constant, to the other side. So let's say we have 2x squared plus 2y squared minus 4x minus 48y. And this is going to be equal to, if I subtract 218 away from each side of the equation, I'm just going to say this is equal to negative 218. Okay? Then what you want to notice is that the coefficient on x squared and y squared is a 2. Okay? You want that to be a 1. So what we're going to do is divide each side of the equation by 2. So I'm going to divide every part here by 2. And what are we going to get? Well, this is going to cancel. You'll have x squared. Then plus, this is going to cancel. You're going to have y squared. Then minus 4 over 2 is 2, so 2x. Then minus 48 over 2 is 24. So this would be 24y. And this equals negative 218 divided by 2 is going to be negative 109. Okay, let me scroll down to get some room going. So what do we want to do now? Now we want to complete the square. So let me group all these x terms together. So I'm going to put this as x squared minus 2x. I'll put a little blank here. And then plus, I'm going to group my y terms together. So y squared minus 24y. Put my blank. and this equals negative 109. Let me kind of slide that down just a little bit so we have enough room. Okay, so what I want to do is I want to take the coefficient for each variable raised to the first power. So in this case, this guy's raised to the first power, this guy's raised to the first power. So take the coefficient, so I'm going to have negative 2. Let me make that better. So I'm going to have negative 2, and I'm going to have negative 24. I want to cut it in half and then square it. I want to take that value and add it to both sides of the equation. So negative 2, if I cut that in half, so times a half, the 2's cancel, and I'm left with negative 1. If I square negative 1, I get 1. So I want to put plus 1 there, okay? But again, to make that legal, I want to add 1 over there. Now, for negative 24, if I cut that in half, if I divide it by 2 or multiply by half, whatever you want to do, that's going to end up giving me a negative 12. If I square negative 12, I get plus 144. And again, I've got to do that over here. I've got to add 144 to make it legal. All right, so let's see what we got now. So this guy right here is going to factor into x minus 1, that quantity squared. And plus, this guy right here is going to factor into y minus 12, that quantity squared. And this will be equal to, if I take 1 and I add it to 144, I get 145. If I have 145 minus 109, I'm going to get 36, right? 36. And essentially, the square root of 36 is 6, so you know the radius is 6 in this case, and you know your center occurs at 1, 12, right? So my center is 1, 12, and my radius is going to be 6. Okay, so looking at this piece of information here, I can get the center and I can get the radius. If I looked at the original equation, you can't really get information out of it because it's got too much going on, right? So when you put it in this format, it makes it easier to grab the center and the radius, and then you can graph stuff pretty quickly. All right, so now let's talk a little bit about graphing circles. This is probably the easiest thing you're going to do in this section. Basically, to graph the circle, if it's in standard form, okay, which we already know how to get to from general form, or if we're just given standard form, if we're lucky, basically, I know the center and I know the radius. So I can just kind of use the definition of a circle and say if I plot my center, okay, I can use the radius to obtain additional points, right? Because from the center to the additional points, it's a distance of the radius. So starting at the center, I can go up by the radius. Starting at the center, I can go to the right by the radius. Starting at the center, I can go to the left by the radius. And starting at the center, I can go down by the radius. So I can use that to kind of plot 4 points. And then I can just draw a smooth curve connecting those 4 points. And I'll have my circle drawn. So to make this a little bit more tedious, and to match something you're probably going to get in your course, I'm going to give you this in general form. We're going to derive the standard form, and then we're going to graph it, okay? So we have x squared plus y squared plus 2x plus 2y minus 23 equals 0. Let's just kind of blow through this. We already know how to do it. Let's add 23 to both sides of the equation. So I'll have x squared plus y squared plus 2x plus 2y is equal to 23. Okay, so at this point, I would check to make sure that the coefficient of the squared variables, so x squared and y squared, are 1. And in this case, each one is a 1, right? So we don't have to worry about that step. So now I would just group the x's together and group the y's together. So I'll say we have x squared plus 2x plus, I'll put a blank here because I'm going to be adding something in there. So then plus over here, I'm going to have y squared plus 2y plus, again, I'll put a blank there. Let me kind of slide this down because I'm going to run out of room. And I'll say this is equal to 23. Okay, so now to complete the square, I'm looking at the variables that are raised to the first power. So this one and this one. And I want to look at the coefficient. So it's a 2 and a 2. So in each case, it's actually the same number, so that makes it nice and easy. So I want to cut the number in half, so divide it by 2 or multiply by half, whatever you want to do, and then square that. So 2 divided by 2 is 1, 1 squared is 1. So I'm going to add 1 here and here to complete the square. But to make that legal, I've added a total of 2 to the left side, so I can add 1 individually like this, or I can just add a total of 2, right? Either way, it's the same thing. So I know that now I can just factor this. So x squared plus 2x plus 1, that factors into x plus 1 quantity squared. This guy is going to factor into y plus 1 quantity squared, right? Because it's basically the same thing with just a different variable. And then this is equal to 23 plus 2 is 25, okay? So now we can go through and we can figure out what is the center, what is the center, and what is the radius, okay? So I know the radius is the principal square root of this number, so that's going to be 5. So that's pretty easy. For the center, again, it occurs at h comma k. So if I just kind of match this up, It's x minus h quantity squared plus y minus k quantity squared equals the radius squared. We already know the radius is 5. But for this guy, if you try to match this up, remember, you have a plus here and a plus here. It is not in the format of minus some number, okay? So what you got to do is make a little adjustment, and I can write this as minus a negative 1, and I kind of can't fit that in there, so let me make that a little better. So minus a negative 1, and then I'll put minus a negative 1 over here. So again, you've got to match the format that you're given, okay? So now I have a minus and a minus, a minus and a minus. So what I can do is I can just grab the number negative 1 and negative 1, okay? So my x value for the center will be negative 1. That's my h. My y value for the center will be negative 1. That's my k. So the center here occurs at negative 1 comma negative 1. The radius is 5. All right, so looking at the graph of this guy, it's already pre-drawn for us to make it a little bit cleaner. Also, I'm a terrible drawer. So I want you to notice that you have the center, which is plotted here. We already know that this occurs at negative 1 comma negative 1. Okay, so this is my center, and we already know that the radius is 5, right? We know that already, so this is 5. So from the center, if I go up by 5, so up 1, 2, 3, 4, 5, I can make a point. Okay, so that's 1 point on the circle, and this guy is going to occur at what? It's going to be negative 1 for the x location, and it's going to be 4 for the y location. Then from the center, I can go 5 units to the left. So 1, 2, 3, 4, 5. So that's another point. This would be at negative 6 comma negative 1. Then from the center, I could drop by 5 units. So 1, 2, 3, 4, 5. So right there. That's going to be at negative 1 comma negative 6. And then lastly, I can go 5 units to the right from the center. So 1, 2, 3, 4, 5. So that's a point there. That's going to be at 4 comma negative 1. Okay, so with those 4 points, I can just kind of draw my circle, and I'm just going to trace over what I already have. Hopefully I don't mess it up too badly. And you can see that I am terrible at tracing and drawing. But you get the idea of what's going on. That's how you can draw a circle. Again, if you're doing this for homework or for a test, the person grading this just wants to know that you know how to find the center and the radius, that you can display those on the graph, and that you can make a somewhat accurate kind of portrait of what's going on. All right, let's take a look at one more of these. So we have 2x squared plus 2y squared plus 12x plus 4y plus 2 equals 0. Again, I can just subtract 2 away from each side of the equation, and I'll have 2x squared plus 2y squared plus 12x plus 4y is equal to negative 2. Notice here that the coefficient for x squared and y squared is a 2. We need that to be a 1, okay, in each case. So just divide everything by 2. And basically I'll have what? X squared plus y squared plus 6x plus 2y is equal to negative 1. Okay, so from here, now I can just go into the step where I'm going to complete the square. And again, I want to group my x terms together, group my y terms together. So we'll have x squared plus 6x and then plus something. And then plus, you're going to have y squared plus, you have your 2y, and then plus something, and this equals negative 1. Okay, so I'm looking at the coefficient for the variables that are raised to the first power. So this x, this variable is raised to the first power. This y, this variable is raised to the first power. So the coefficient is a 6 and a 2. Okay, so that's what we're looking at. So cut it in half and square it. 6 divided by 2 is 3. 3 squared is 9. Cut it in half and square it. 2 divided by 2 is 1. 1 squared is 1. So this would factor into x plus 3 quantity squared. This would factor into y plus 1 quantity squared. This equals, again, when I added 9 here and I added 1 here, I've got to add a total of 10 to this side of the equation to make that legal. So I'm going to put plus 10 here. And so negative 1 plus 10 is 9. And so now we have this guy in center radius form, okay? So what we want to do, again, is match it up. Because you have this plus sign here and plus sign here, it's going to throw you off, okay? I know already because I've solved so many of these problems, the center occurs at negative 3 comma negative 1, and the radius is 3. But again, if you're just starting out, write your formula and match it up. So x minus h quantity squared plus you have y minus k quantity squared, and this equals, you're going to have your radius squared, okay? So the radius is easy. Just take the principal square root of 9. That's going to be 3. So the radius is going to be 3. And then this guy right here, again, I'm just going to write it as minus a negative. So x minus a negative 3, so that it matches up with what we have there. So my center is going to occur at negative 3, comma. Again, this guy, I'm going to write it as y minus a negative 1. Okay, so this matches up with that. So negative 3, comma, negative 1 is going to be the center. Okay, so this is my center. All right, so let's plot negative 3, comma, negative 1, and then use the radius to get additional points. So here's negative 3, comma, negative 1. Again, I'll just label that. It's negative 3, comma, negative 1. That's our center. And then my radius is 3. So I go up by 3. 1, 2, 3. Plot this point here, which is negative 3, comma, 2. And then you can go to the left by 3. So 1, 2, 3. So this is going to be negative 6, comma, negative 1. And then you're going to go down by 3. So this guy right here is going to be negative 3, comma, negative 4. And then you're going to go to the right by 3. So this guy right here is going to be 0, comma, negative 1. Okay, so those are your 4 points. And again, I can just connect them with a smooth curve. And I'll just have my circle drawn. All right, so let's wrap up our lesson and talk about just one more commonly occurring scenario that you're going to get when you're working in the section on circles. So you might be asked to find the center radius form of the equation of a circle, given that you have these kind of endpoints that represent the diameter of the circle. So let's suppose that we have a circle that has a diameter with endpoints negative 1, comma, 3, and then 5, comma, negative 9. So again, before I kind of jump in and show how to solve this, let's look at a little graph real quick. So I just took the first graph that we looked at with the center labeled as h, comma, k, and a given point labeled as x, comma, y. Again, I know there are real coordinates here, but I'm just labeling this generically so we can get an idea that would work for kind of every scenario. Okay, so we know that the radius is the distance from the center, h, comma, k, to a given point, we said x, comma, y. So that's this distance from here to here. So that's r, that's the radius. If I doubled that amount, okay, so if I had a radius over here as well, if I drew kind of in a different color from here to here, 2 of those guys would be known as the diameter. Okay, so the diameter is twice the radius. The diameter is the length of a line that passes through the center and touches 2 points on the edge of the circle. So if I just think about this as one line, I'm going to do a final color here. So if I think about these 2 endpoints and I do one line all the way across, that distance there would be the diameter. Okay, so that's what we're thinking about here. Now, if I'm asking you to find the center, and let's say I know this and I know this, well, I need the point exactly in the middle of this line segment. How do we find that? We use the midpoint formula. So I want to go back here and I want to use my midpoint formula so I can find the center, right? I need to find the center radius form. So I got to find the center and I got to find the radius. So the center, again, I use my midpoint formula. So the midpoint formula, it's x sub 1 plus x sub 2 over 2, right? The average of the x values, and then the average of the y values. So y sub 1 plus y sub 2 over 2, okay? So I can label either as whichever you want, right? We can say this is x sub 1, y sub 1. We'll say this is x sub 2, y sub 2. And let's just plug in. So you'd have negative 1 plus 5. That's going to give me 4. 4 divided by 2 is 2. So this would be 2. And then for y, I would have y sub 1, which is 3, plus y sub 2, which is negative 9. 3 plus negative 9 is negative 6. Negative 6 divided by 2 is going to give me negative 3. Okay, so this is negative 3. So this guy is going to be the location of my center. So this is my center. Okay, so I want you to remember, let me just kind of erase this and I'll put this over here. So I'll say my midpoint, and actually I'm just going to label it as the center. So my center is going to occur at 2, comma, negative 3. And we know our center radius form. It's going to be x minus my h. In this case, h is going to be 2, right? So it's going to be 2, that quantity squared. Then plus, I'm going to have my y minus k. In this case, k is negative 3. Minus a negative 3 is plus 3, and this is squared. This equals my radius squared. So now what I need to do is figure out the radius. I need to figure out the radius. Now, by definition, I know that the distance from the center to any point on that circle is going to be the radius. So I can just use my distance formula with one point. I'm just going to choose this one and the center, and that's going to give me my radius. I can plug it in and I'll be done. So we've got 5, comma, negative 9. 5, comma, negative 9. and we've got 2 comma negative 3, okay? And again, we can switch up the labeling. We can say this is x sub 1, y sub 1, and this is x sub 2, y sub 2. And just so you don't get confused, I'm going to erase this, right? This has nothing to do with what we're doing now. So let me scroll down. All right, so the distance between these 2 points, again, from a point on the circle and the center, is going to be my radius. So instead of saying d for distance, I'm going to say r for radius. This is equal to the square root of the difference in x values. So you have x sub 2 minus x sub 1. So 2 minus 5. So 2 minus 5, that quantity squared, plus the difference in y values. So y sub 2, which is negative 3, minus y sub 1, which is negative 9, minus the negative 9 is plus 9, this quantity squared, okay? So 2 minus 5 is going to be negative 3. Negative 3 squared is positive 9. So this is 9. Negative 3 plus 9 is 6. 6 squared is 36. So if I add 9 and 36, I get 45. So I get the square root of 45 here. Let me just kind of clean this up a little bit. So I know that 45 is what? It's 9 times 5. So it's 9 times 5. Square root of 9 is 3. So I can say this is 3 times square root of 5. And so this is my radius. So I can plug that in here. So I would have what? I would have 3 times square root of 5. But then this guy is squared, okay? So let me erase all this. So to finish this up, if I square this guy, remember to square each part. 3 is going to be squared, which gives me 9. And the square root of 5 is going to be squared, which gives me 5. So 9 times 5 is 45. So this becomes my equation of this circle in center radius form. You have x minus 2, that quantity squared, plus you have y plus 3, that quantity squared, and this equals 45.